Here's another practice problem. Integral of cosine of 2 pi t plus 5 dt. I would start by saying u equals something, du equals something. So figure out what those would be. You probably got 2 pi t plus 5 for u, and then 2 pi t plus 5 prime dt for du, which would be 2 pi times 1 plus 0 dt, or just 2 pi dt. You don't have to show this step or even that step if you don't want to. If you can just take the derivative of 2 pi t plus 5 in your head, you can just go du equals 2 pi t dt. That's fine. And then we want to get dt all by itself, so we divide both sides by 2 pi. And then we can rewrite the integral. Cosine of u times, replace the dt with 1 over 2 pi du. Integral of cosine is sine, negative sign, positive sign, times 1 over 2 pi plus c. Substitute back, you get sine of 2 pi t plus 5 times 1 over 2 pi plus c. Okay, so far. Can you simplify by bringing the 2 pi underneath? Well, you can if you bring it under the entire thing, but you can't just bring it under this part in the inside. So that's not equal to sine of 2 pi t plus 5 over 2 pi plus c. So I would actually just leave it like that. You could move it out front or something, but really there's not much benefit in doing that. Let's talk about some other trouble spots. Here the trouble wasn't in doing the u substitution, it was just in maybe getting too ambitious with simplifying it at the very end. So let's look at some trouble spots. Let's do that same thing again. Integral of cosine 2 pi t plus 5 dt. Can I say that this is the integral of sine of u times 1 over 2 pi du? What do you think? Well, I have replaced the u, the 2 pi t plus 5 with the u, and did the du dt thing, but I already took the antiderivative of cosine and got sine, so I shouldn't still write the integral. So I could either keep writing the integral, if I'm still writing a du, I should still be writing the integral, right? But then I shouldn't take the antiderivative of cosine. So we'll say nope. Since we still have the integral and the du, I shouldn't take an antiderivative yet. So I should do it the way we did up here, still write the cosine with the integral and the du and the 1 over 2 pi, and then in a separate step take the antiderivative and then not write the integral sign anymore, not write the du anymore. So that's a trouble spot. Another trouble spot, if I had the integral of x squared plus 3 to the 5th dx, you'd say u equals x squared plus 3, right? That's clearly the inside thing. Du equals 2x dx, and then 1/2 du equals x dx. Okay, so far. And then let me try one thing and another thing. Can I write this as the integral, replace this with u to the 5th, and then I still have the x and the dx? What do you think? Well, I would say this is technically not wrong, but very, very likely to lead you into trouble. So I'd say this is confusing. Like if I'm integrating with dx, why is there a u in my formula? So I'm going to say don't mix x and u in the same formula here. So in the same integral expression, that's going to lead you into trouble. Another thing people might write would be integral of x times u to the fifth du, which is not only confusing, but it's also wrong. It hasn't taken into account this 1/2 that we need. It just kind of plain old substituted dx with du. So what's the right way to do it? So we'd say integral of u to the fifth, changing out the inside stuff to the fifth with u, and then the x dx gets replaced with 1/2 du. What's the integral of u to the fifth? It's 1/6 u to the sixth plus c, times 1/2. So that's 1/6, and then substitute back, x squared plus 3 to the sixth times 1/2 plus c. And we're done. We should check it by taking the derivative. So the good news is we're now done with the material for part 1 of the chapter 6.1 homework, all the antiderivative, all the indefinite integral stuff. So go do part 1 of the homework. But we don't do part 2 homework yet because that'll be the next set of videos.